I'm sensing there's still a bit of uncertainty and a bit of hesitation, so I'm going to go maybe a little slower than I normally might going over this. We'll still start out with good old Anne. If I was solving this, I would go, okay, a football player of mass 82 kilograms is running due north. I would make a note of direction. He collides with another player. Okay, as soon as I see two players, I'm thinking this is probably going to be a collision. They said the word collides. This is going to be a job for conservation of momentum. So now I'm going to be lazy but organized. I'll call this mass A. I'm going to call north positive. Here's mass B. And it's south, so I'm going to call that negative. And then I notice they stuck together. They want the final velocity after the collision. I would probably start out by writing the sum of all the initial momentum equals the sum of all the final momentum. And now I'm going to say before the collision what's moving. It looks like I have mass A and velocity A initial and mass B, velocity B initial. Bam! They collide. After the collision, stuck together. What does stuck together mean? Mass A plus mass B, V final. Another good example, this would be an identical question to an arrow hitting a target. Oh, except it would be easier because the target is probably at rest. Your second velocity would be 0, so your second momentum would be 0. Madison, you could probably get rid of that whole term. Okay? What do they want me to find? So as far as I'm concerned, by the way, Sadie, I can have you find the initial velocity of the first guy, the initial velocity of the second guy, or their final velocity after sticking together. You can get any of those by itself. Here they want me to find V final, so I would go V final is going to be M A V A initial plus M B V B initial. Have I got enough room, Mr. Dewick? Good, I do. All over MA plus MB. Now I would start to plug in numbers. VF equals MA 82 positive 77.5 plus MB 65 negative 8.1 all over 82 plus 65. If I'm visualizing this, a heavier player traveling slower collides head-on with a lighter player traveling faster. I'm not sure who's going to win here. I don't have a gut instinct for this one, but I certainly wouldn't be looking at my phone or anything foolish like that right now. That would be silly in the extreme. I probably have it completely put away, so it wasn't a distraction at all. Right? Right. Absolutely. So I don't know whether I'm going to end up with a north or a south here. 82 times 7.5 plus 65 times negative 8.1. Close off the top, divided by, open up a bracket, 82 plus 65. If I get a positive answer, what direction will that be? If I get a negative answer? South. Unless you let south be positive and north be negative, but we'll still get the same direction at the end. I got positive 0.602, is that correct? So if you got that, I would give you 3 out of 3. Otherwise, I would probably go 1, 2, 3, 4, 5. Yeah, I would probably go a half mark if I saw that, a half mark for that equation, a half mark for getting the V by itself, a half mark for the numbers, a half mark for the magnitude, and a half mark for the direction. Okay. So there's going to be at least one collision where stuff sticks together. What else can I ask? Ooh, number 2, here I see one mass. This is probably going to be an impulse question. Oh yeah, it wants me to find the impulse. First thing that I would do, Bryce, is I would change 52 grams to 0.052 kilograms. It's divided by 1,000. Hits the ground at 8.2. You know what, Bryce? What word did I just underline? That means is a change in direction. I decided to let up be positive and down be negative. Could have done the other way around, but I have to do one of those. They want me to find the impulse. Impulse is change in momentum. I noticed they gave me a final and an initial velocity. So Sarah, I said I'm going to use mv final minus mv initial, which is on my formula sheet a little bit in disguise with the delta, but change in anything is final minus initial. The impulse is going to be 0.052 times 6.2 minus 0.052 times negative 8.2. The impulse is 0.052 times 6.2 minus 0.052 times negative 8.2. I get 3.55. Is that correct? Am I wrong? Nobody nodding. Let me check my typing. Oh, you know what? I got a typo. First line right there. Try that again. 3.666. Is that better? Nobody nodding. Okay. I missed another 0. Wow, Duick. I put the 0. Oh, I know what I did. I typed them in the wrong order. Okay. I don't have a negative 6.2. No, I let up be positive because that would make way more sense to me. You get 0.764. Is that the right magnitude? Yeah, am I typing? It's 8.2. Wow, did I make more typos on one question or what? Wow. Is it 0.7488? Yeah. Okay. Geez, Duick. 0.74. I'll go 0.749 if you went 0.7488. Now, that's the magnitude. What's the direction? I got a positive answer. Which way did I let be positive? So, up. If you let up be negative, you would get a negative answer. So if you got this, I would give you 2 out of 2. Otherwise, I would give you a half mark for the impulse equation. I would give you a half mark for that. I would give you a half mark for the magnitude, and I would give you a half mark for the up. Probably the most common mistake, aside from the bunch that I made, is missing that there's a change in direction. So if you missed making one positive and one negative, you would get an impulse of negative 0.104. I would give you 1 mark for that, not 2. I give you 1 out of 2. That's a pretty serious error in my mind. What's the average force of impact? You could go F equals ma. I chose to go impulse equals 0.74. Well, you know what? It equals impulse. And I said the force is going to be the impulse divided by the time, which is going to be 0.7488 divided by, they gave me a time, 0.15. And I got a force of 4.99 newtons. And if you wanted a direction, since I also got a positive answer, of course the ground is pushing up when something bounces off it. Okay? There, I would give you probably a half mark if I saw that, a half mark for that, a half mark for the magnitude, and a half mark for the answer. Turn the page. Again, I see 1 mark. They want the average force. There is enough here that you could go F equals ma, and I would be fine with that. But I chose to go impulse equals impulse. Oh, not final, Mr. Duick, initial. Because then I was able to say, you know what? The force is going to be mv final minus mv initial. all over T. By the way, if you look really closely, you can see this is F equals ma in disguise, except instead of A, I did Vf minus Vi over T, which, oh yeah, that was acceleration. So it's just a time saver. It's going to be 1200 25 minus 1200 times 12 divided by 8. They just wanted the magnitude, not the direction, so okay. 1200 times 25 minus 1200 times 12, close bracket, divided by 8.
You put it times.
Wow, am I typing badly today? You get 1950, and that's newtons, and that's magnitude, so I'm not going to give a direction. If you pressed me pretty clearly, the direction would be forwards because the car sped up, but is that okay, Madison? If you got that 2 out of 2, otherwise I would give you a half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. Ooh, they want me to find the change in velocity. Okay. I'm still going to write impulse equals impulse, but it's going to look like this. Force times time equals m delta v. Bryce, what's the m doing to the delta v? Adding, subtracting, multiplying, or dividing? So how will I move the m over? So you're telling me, and I think you're right, the change in velocity is force times time divided by the mass. Is that correct? What is the force in newtons in this question, Bryce, my friend? What's the time? What's the mass? Plug and chug. Do you get 24? So what does that mean? That's what this car's velocity changed by. If it was going 1 originally, now it's going 25. That's a change in velocity of 24. If it was going 5 originally, now it's going 29. That's still a change in velocity of 24. If you got that 2 out of 2, otherwise I would probably go something like this. Half mark for that, half mark for that, half mark for that, and a half mark for the numbers. George and Jim, I see a collision. This is going to be conservation of momentum. I said, George, mass A. I'm going to call east positive. Jim, mass B. I'll draw a little arrow pointing there. West, negative. After the collision, George slides with positive east. So I guess we have a head-on collision. George keeps going. I'm kind of guessing Jim maybe got pushed backwards. He got blowed up. This is a pretty big collision, I suspect. Is this a collision? Conservation of momentum. The sum of all the initial momentum equals the sum of all the final momentum. Before the collision, who's moving? You know what? This was dumb. How about instead of using A and B, I'm going to use G for George and J for Jim. That makes way more sense to me. Then I can just keep track of this. So I have mass George, velocity George initial, plus mass Jim, velocity Jim initial. Wham, they collide. Do they stick together or are they separate? Separate. Okay. Pause for a second. So separate, we're going to have mass George v. George final and mass Jim v. Jim final. What am I trying to find? I guess I'm going to get this by itself. How? Left side's going to drop down, then minus mgvg, and divide by m. Oh, I can do this. We've come a long way in our formula manipulation. So it's going to be mass George, velocity George initial, plus mass Jim, velocity Jim initial, minus mass George, velocity George final all over Mass Gym. Showed you that video already. Time to plug in the numbers. The final velocity of Jim. Again, I'm kind of expecting that Jim ends up changing direction and going backwards. So I'm thinking, since he was initially coming in west, I think he's going to end up going east, but we'll find out. George was 65 times positive 12 plus 85 times negative 4 minus Mr. Dewick. 65 times positive 4. All divided by 85. Bracket. Did I make a mistake? Okay. 65 times 12 plus 85 times negative 4 minus 65 times 4 divided by 85. You got 2.12?
Yeah.
2.12 meters per second. It said magnitude and direction. I got a positive answer, so east. If you got that, I would give you 3 out of 3. Otherwise, 1, 2, 3, 4. Yeah, I would probably go half mark for that line, half mark for that, half mark for that, half mark for the numbers, half mark for the magnitude, and a half mark for the direction. Can you give yourself a lovely score, please, at the top out of 14?